Hello, this is a lesson on gravitational potential energy, so that should be your title today. So if you've not got your books out, can you get them out and can you pop that down, underlined as your title, and obviously today's date. Pause this if you need to have some time to put that in. And we're going to be looking at what gravitational potential energy is and how it can affect different objects and what different factors can affect it as well. So I'm going to go through some bits with you. I'm going to tell your teacher to pause the video and you should be able to answer some questions, or I might ask you to show what you understand from something, and then go on to the next sort of step of this. So we'll start off by going through what it is and the factors that can affect it, and then we'll have a look at some calculations as well and how we work it out. So start off with, we've got our little man here. He's going to show us what I'm talking about with gravitational potential energy. So we should have talked about already, we've done a lot of talking about lifting books up in the air to give them gravitational potential energy. So with our little man here, if he jumped up in the air, he would be gaining gravitational potential energy. So every time he jumps up in the air, he's gaining gravitational potential energy using his chemical energy. Because gravitational potential energy is the energy an object has due to its height from the ground. Okay, so that is the first factor that affects the gravitational potential energy something has. So its height from the ground. So for example, if our little guy here came along and he climbs up a ladder, okay, he has gained gravitational potential energy by going up the ladder. Okay, so he's gained height, so he's got more gravitational potential energy. I'm going to keep calling it that, but I might type GPE, gravitational potential energy. So he's gained height, so he has gained gravitational potential energy. Sorry. So as he goes up the ladder, every step he takes up the ladder, he's getting higher off the ground, and therefore he's gaining more energy. So that's our first thing. So height is our first factor that affects it. Now, think about if he had to climb the same ladder, but this time he was carrying a big weight. So let's give him a big weight to carry it. Okay, so he's carrying a big weight in his hands this time. And he's doing the same step up the ladder. Now this time, because he's carrying the weight, okay, or more mass, it's going to take him more energy. Okay, and that's the second thing that can affect gravitational potential energy, the mass. Okay, so the more mass you have, the more gravitational potential energy you're using. So by climbing to the same ladder, but this time he's carrying something heavy, he is using more gravitational potential energy. Right. Moving on. Now, slightly different to this, if we think about if he was on the moon, so a bit abstract now, he's not been on Earth so far, okay? He's been on Earth, he's been climbing up his ladder. We've said the higher up he goes, the more gravitational energy he has, and the more mass he's having to carry up the ladder, the more gravitational potential energy he'll have. Now this time though, think about if he was on the moon. Think about, would it take more or less energy to climb up the ladder? So it would take a bit less. So because he's on the moon, gravity is less. Okay, so less gravity. So because the gravity is less strong, he's got less gravitational potential energy on the moon than he would on Earth. And that's the third factor that affects gravitational potential energy, the strength of gravity on the planet that you're on. So the stronger the gravity on the planet, the more gravitational potential energy you would have. Okay, so a bit of time for you to do something now. So I want you to copy and complete these sentences. Okay, so gravitational potential energy is the energy that something has due to what? Okay, it can be affected by three things. So two things and then something about the planet that you're on. So you want to fill in those spaces with the three things that we've just discussed. If you need to go back and watch little bits again, okay, then hopefully your teacher will be able to go back and watch those bits again. If you need to, but you now need to pause this and give yourselves time to write that in. Okay, so if you pause now, I'll show you the answer in a second. Okay, so show the answers now. So we should have said gravitational potential energy is an energy something has due to its height above the ground, so due to how high up it is above the ground. It can be affected by the mass of the object, the height of the object, and the gravity of the planet it is on. So those three things can affect it. Okay, so we're going to have a quick test to see if we can understand these things properly now. So I'm going to show you a couple of pictures, and I'm going to ask you to show, if you just show it using your hands, say just do like 1 or 2 fingers, I know you haven't got whiteboards, to your teacher, what object has more energy? So can you just decide and show your teacher which one you think has more gravitational potential energy? Do you think it's 1 or 2? Okay, so hopefully we've shown the answer, and the answer should be number 2, okay, because 2 has more height. Okay, next one. This time, which one has more gravitational potential energy? Okay, this time it should be number 2 because it's got more mass. Okay, now about this one. So which of these objects do you think would have more gravitational energy? So it would be number 1 on Earth or number 2 on the Moon. So I'll just give you a second, pause it if you need to. Okay, so the answer would be number 1. So because the Earth is bigger than the Moon, it means the Earth has a higher force of gravity pulling you down. So there's stronger pull of gravity pulling you down. So the Earth has higher gravity than the Moon, and actually the Earth's gravity is 10 newtons per kilogram. That means every 1 kilogram of stuff on the Earth weighs 10 newtons, or has 10 newtons force pulling it down. And on the Moon, that's only 1.6, so every 1 kilogram takes 1.6 newtons to pull it down. So in this case, the one on the Earth is going to have much more gravitational potential energy than the one on the Moon. Now you need to write this down in your books because you might need that later. Now you might want to write the Moon one down as well, but the main one is you need to know that gravity on Earth is 10 newtons per kilogram. Now it's actually 9.8 newtons per kilogram, but for today we'll round it up to 10 just to make things a bit simpler. Okay, so just pause it in a second again if you need to, while you write down that gravity on Earth is 10 newtons per kilogram. Right, now we're going to have a look at the equation. Okay, so if we're ready, move on. Now the equation to find gravitational potential energy is this. So we've got our word equation up at the top. So gravitational potential energy equals mass times gravitational field strength times height. So because all these things increase the energy, we times them all together to get the energy. We'll go through the symbols. So the symbols, we've done a lot of these before. We talked about why these things are what they are, and these ones aren't too bad. So EP is for energy, and it's potential energy because gravitational potential. So we call it EP equals mass m times g for gravity times h for height. Now, if we think about what our units are going to be, we should know that because it's energy, the units for energy are going to be joules. We should know mass should be measured in kilograms, so we might have to turn things from grams into kilograms. We should know that gravity, well, we don't know, right, we'll come back to gravity. We should know height is measured in meters, so again, if it's in centimeters, you want to turn it into meters. And gravity is measured in newtons per kilogram. Okay, so it's how many newtons to lift 1 kilogram. And the unit symbols are here, so J for joules, kg for kilograms, N/kg for newtons per kilogram, and M for meters. So Obviously, again, we might need to pause this and this whole thing. We've done this a few times now, so you should know what you're doing with this. This whole thing, all of it, needs to be written down in your books so that you've got it there and you know what this equation is with all the units and everything. Okay, so pause the video again. Okay, so I'm going to go through an example of a question now, and everything I write down on here, I want you to try and write down as well as what a good one looks like in your books. If you've got a little subtitle in your books now, waggle. Okay, so just write waggle in your books, and you're going to write down everything I write down as we go through this. So the first step all the time when we're doing equations is to read the question really carefully, and we've talked about this before about going through and highlighting it. So I'm going to go through and highlight this and see what I've got. So as I go through this, I've got first off 10,000 kilogram car, and that is my mass because it's in kilograms. It's lifted by a ramp up to a height of 200 centimeters. Now 200 centimeters, if we look back to our equation, we want our distance, our height in meters, not centimeters. So to turn that into meters, okay, this is the first thing you'll write down. I'm going to write that I'm going to do 200 divided by 100 equals 2 meters. Okay, so my height is actually 2 meters, not 200 meters. Now, also, what it doesn't say on the question, oh yeah, but you do know, is that gravity is 10, because we know that gravity is 10. Okay, we said before, gravity on Earth is 10, and this car is on Earth. We assume it's on Earth unless we're told otherwise. And it asks us how much gravitational potential energy has it gained. So that's what it's wanting to know. So our first step after we've read it is to write our formula down. So our formula being, I'm going to write it in shortened, and I suggest you do the same as well because it saves you some time. So EP, gravitational potential energy, equals mass times gravity times height. Okay, so mass times gravity times height. So go through. Do we know the energy yet? Okay, no we don't. So we just put EP again, equals, we do know the mass is 10,000. Okay, times, we know what gravity is because it's 10 newtons per kilogram on Earth, and the car is on Earth, times our height of 2 meters. Okay, so you're writing this down as I write it down. So this one's pretty simple because all we need to do now is calculate that. So I'm going to type that into my calculator, and you should, if you've got a calculator, can you do the same, please? So 10,000 times 10 times 2 equals 200,000. Okay, so EP equals 200,000. And we're missing one thing off the end now. We need to buy units, which are joules. So yours should look exactly like this. Okay, so pause it now if you need to have some bit of time to write that down. Okay, and then I'm going to put some more questions up on the board for you to have a go at. So the first ones should be relatively simple. Okay, it should just be going through a few pretty simple questions. Okay, but once we get onto these ones down here, we have some like converting units. We've got grams when I turn that into kilograms, divide by 1,000. Centimeters when I turn that into meters, divide by 100. Things like this. Okay, and then some here further down where we're getting a bit more difficult. Okay, so have a go at those. Pause the video again now and take your time going through each of those 11 questions, as many as you can get through. Okay, so pause it now and go through all those. Right, if you've had a chance to get through all those, I want to go on to some slightly more difficult questions if we think we're ready for it. So this question, and we'll read through it again. So we've got an object 12 meters in the air, and it takes 2,400 joules of energy to do it. So we've both got two numbers, both in the right units we want them to be. Okay, but this time we know the energy and we want to know what is the mass. Okay, so I'll have a look. We'll go through this and look at what we need to do. So first thing, write our formula down. Energy equals mass times gravity times height. Then we put our numbers in. So this time we know the energy is 2,400. We know gravity is 10, and we know height is 12, but we don't know mass. So put those numbers in there. And now we look at what can we do. Oh, I'm going to change that to 10. We'll round this up a bit. Okay, so we think, what can we do? Right, we can do 10 times 12. which will be 120. Sorry, I've just used slightly different numbers for this. But we can do that. We can do 10 times 12 is 120, and we end up with this. 2,400 equals mass times 120. So now what we need to do is 2,400 divided by 120 to give us mass. So 2,400 divided by 120 gives us a mass of 20 kilograms. So you can write this down as another waggle in your books, and I'll give you some more difficult ones to have a go at then. So again, just if you put your numbers in first, this is the vital step. Put your numbers in without rearranging. So just go through. Do I know my energy? Write it in. Do I know my mass? No, so I'll just put M. Do I know gravity? Do I know height? And it might be that you don't know gravity sometimes. It might be on a different planet. So you put your mass in, and your height, and your energy, and you don't put gravity. Then think, what can I do? So I can do 10 times 12, so I do that, and that simplifies it to a point where we can then think, right, that's got to be that divided by that. Okay, and ended up with an answer. So a bit more difficult, and there's some more here to have a go at. Okay, some more challenging ones. But if you're ready to have a go at those, again, some of them you need to do your converting units. I've got kilojoules here, so kilo means 1,000, so that'll be 27 times 1,000 to get you that one. Okay, so work out as many of these as you can. Remembering if it's on Earth, like I'm on Earth on this first one, what gravity will still be 10. Okay, so you should just use gravity as 10 unless it's something like this one here, which says gravity on Mars. It wants you to find the gravity on that one. Okay, so again, pause the video and go through these, and then that hopefully should take you to the end of your lesson.